Okay, so recording has started. So what I was saying is that we have from the final exam review, right? For applied maths, we have chapter 4, chapter 5, chapter 6, basically. Not all, but few topics. So from chapter 4, we have 4.4 and 4.5. From chapter 5, we have 5.2, 3, 6, 8 or 9. And chapter 6, we have 1, 2, 3, 4, 5. Uh, and then the last lecture was about curvature that is given in 12th chapter, but I will recommend you not to see 12th chapter because it will be confusing. Notes on Moodle. So as I said, from chapter 4, I will give you one question. So most probably the question will be from 4.5, but 4.4 will be needed, right? So 4.4 needed for 4.5. So if question comes from 4.5, you will still need to prepare this one. Now this one, I will not give you any question from here, but this is needed for chapter 6. Okay, because in chapter 6 you have to do the integration application. So if you don't know the integration, of course you cannot do the application. So in 6.1, it's area problem, area between two curves, right? So I one question from there. Then 6.2 and 6.3, they both are volume problems, volumes of solids of revolution. We revolve an area about x and y axis and it becomes a solid. So when it becomes a solid, we find that volume. So I'll give you one question from here, right? Maybe two parts, one part from 6.2, one part from 6.3, like that. And then you have 6.4, 6.5. 6.4 is the length of arc length of a curve. 6.4 is the surface area. So they both have similar formulas, basically. Length of a curve has little smaller formula, and that formula is used in 6.5. So most probably I'll give you a surface area problem, right? One question from there. And then the last one, the curvature, has one question. Okay, so you got 5 questions total. 3 questions from chapter 6, one question from chapter 4, and one from curvature. Curvature is a very simple formula. Most of the formulas will be given. Okay, so see in 6.1, you have area between two curves. So if you have two curves given, y is equal to f of x, y is equal to g of x, these are the two curves between the values a and b, this area, you want this area between two curves. So what you do, you integrate from a to b. This is your integration, right? So basically you draw this straight line here and see this line can go anywhere. So if you draw a line here, right? So this is at anywhere x in between a and b, in between these two values. So see now this x can start from a and it can end at b. So I need the length of this line. So the length of this line is fx minus gx, right? The upper point is fx, the lower point is gx. So if you subtract fx minus gx, you get the length. So that's how you can remember the formula, fx minus gx, or the top curve minus the bottom curve. This gives you the area. Or sometimes you are not given curves, you are given the values of y instead of x. Y goes from C to D. So you have a left curve and a right curve, like that. So your now the limits are straight lines in y-axis. So the right curve will be x is equal to f of y, and this will be x is equal to g of y. So see, now x is given in terms of y, and y goes from 1 to x. So I will take any value here in the interval and draw a line. See, when I took x here, I draw the vertical line. When I took y here, I draw the horizontal line. Now the length of this horizontal line is fy minus gy. This length is fy minus gy. So I will integrate now this fy minus gy with respect to y now, and the limits of y goes from c to d. So area can be in x direction or it can be in y direction. So both are given there. So if I open the book, chapter 6, I can go straight from chapter 6. So see here, you can see these are the area problems. So see, if you have upper curve minus lower curve from A to B, and if you have y-axis, then you can go from left to right. See, if you have from C to D, see, if you are between C and D and your curves are right and left, then you can use this formula. So I can go to, for example, this question or any other question. So example here you see sketch the region enclosed by the curve. So I'll give you most probably this type of question where you have to sketch the region, right? So sketch the region drawn by the curve. When we give sketch, then the curves will be easy. I will not give you something like this. Sketching this curve is difficult. X cube minus 4x, not like that. Yeah, sine x can be given. X square is equal to y, x equal to y square, they can be given. So for example, this question number 7, uh, y is equal to x square, y is equal to square root of x, then x 1 by 4 and x 1. So see, these two are lines, x equal to 1 by 4 and 1. So let's see if I want to sketch it, y is equal to x square is this. This is y is equal to x square on the left as well, but I don't need left because my points are on the right side. Y is equal to x square. And y is equal to square root of x is this. This is a square root function. So basically, there are 2 points from 0 to 1, right? So this point is 1. You can find the intersection x square equal to square root of x, right? So here your y value is equal, right? Y value is equal, and you want to see what your x here is. So you can equate y values. So this is x4 is equal to x. So x4 minus x equal to 0. If you take x common, x cube minus 1 equal to 0. So from here you will get x is equal to 0 and x is equal to 1. So see, you got two values, x is equal to 0 and x equal to 1. So, but they already gave me x equal to 1. So this value was given to me. The second value is given 1 by 4. So 1 by 4 is somewhere here, right? Here is 1 by 4. So they are asking you this area between 1 by 4 and 1. This area is being asked. So now if you draw any x here and draw a vertical line, your upper curve is square root of x and the lower curve is x square. So it means this distance will be upper curve minus the lower curve. So your area will become uh, from 1 by 4 to 1. Curve which is above is square root of x and curve which is below is x squared dx. Okay. So now I can integrate this and get the answer, right? So integration of x is x to the power 1 by 2 plus 1, which is 3 by 2 divided by 3 by 2. Now these formulas are given in 5.2. So if you don't do 5.2, of course, you will be stuck here. So x cubed by 3. And that is the chapter 5 was done in calculus 1. I also did it, but it is the topic from calculus 1. So you should definitely remember. So I can replace the value 1. Then we put this value first and then this value, right? So if I put 1, it will become 2 by 3, 1 to the power 3 by 2 minus 1 cubed by 3, right? And then if I put 1 by 4, you got 2 by 3, 1 by 4 to the power 3 by 2 minus 1 by 4 cubed by 3. So you can use calculator and write the answer. So that's how you can find the area between curves. So again, if I recall, simple curves that you remember should be this is y is equal to x square. If you have this is just square root of x, but if you complete the parabola like the black one, right, then this is x square is equal to y square. If you have y is equal to x square, it is with y-axis. If you have x is equal to y square, it is with x-axis. But if you only take this top portion, if you only take this portion, this one, right, that is y is equal to square root of x. Okay, from here, you see, if I take the square root, it will give me plus and minus square root of x. So plus square root of x is above and minus square root of x is below here. This one, this down portion is minus square root of x. So there are two curves in the blue one. If you write the blue curve together, then it is x is equal to y square. But if you write them separately, it is y plus square root and y minus square root of x. X square x, y is equal to x is just a straight line. Y is equal to x. So if you add a number, if y is equal to x is there, if you add something, it will just go up. It will come here. Y is equal to x is this. This will be y is equal to x plus some number. If you go down the same line, it will become y is equal to x minus something. Okay, so if you subtract, it will go c units down. If you add, it will go c units up. So that is the translation basically. So these are straight lines. If you have a minus sign with x, then it comes down. This is y is equal to minus x. So if you add something in it, it will remain the same, minus x, but plus some number, right? If you go down, it will be minus x minus some number. Minus x minus some number, 1, 2, 3, whatever. So these are straight lines. So these are some useful graph that you can remember. Sin x starts from 0 and it goes like this, right? This is the graph of sin x. And if you have a cosine x, cosine start from 1 and it goes like this. They have the same graph, but they are starting from 0 and 1. Sine starts from 0, cosine starts from this number 1. Okay. So at pi by 2, you see here, at pi by 2, your sine is 1, but cos is 0. At pi, your sine is 0, but cos is minus 1, and so on. Similarly, minus pi, your cosine becomes minus 1. Pi by 2, your cos becomes 0, and sine is minus 1, and so on. Tangent is a straight. Tangent is between minus pi by 2 and plus pi by 2. It goes to infinity, basically. It starts from 0, goes to infinity. Start from 0, it goes to infinity. This is your tangent x between pi by 2 and plus minus pi by 2. So these type of graphs should be in your mind. E log of x and ex. This is your ex function, and inverse of that is your log x. Log x starts from minus infinity. It is not for negative numbers. So see, at 0, when x goes to 0, log goes to minus infinity. But here, ex remains positive for all values of x. So maybe they can help a little bit. In 6.2 and 3, we find the volume of solid of revolution. What is a solid of revolution? That if you have a curve, let's say y is equal to f of x is a curve, and between A and B, you have an area, right? This is the area region. This is the region in first quadrant, let's say. Now, if you rotate this area about x-axis, right? About x-axis, if you rotate this area, right? So this means rotation, revolution about x-axis. Okay. So what we are saying that revolving about x-axis or rotation about x-axis. Then what happens? You see this curve, this point will come down and goes up, right? So this curve will go become like this. It will come down, it will go back, it will come down. So it is every point is rotating in circles. So if I take any point here between A and B, I will get this radius because this point on the curve comes down and it goes back up. So see, it become a circle here whose radius is this height. This height is f of x. You see, at any point x, my function gives me this height fx, right? So this height is f of x. So radius is f of x. So this is the area of circle. Area of this red circle will become pi radius square. Radius is fx square. And now you have to see, you have to integrate this from minus, you have to add all these areas from A to B, x goes from A to B. So that's how you can remember the formula, but it will be written in your paper as well. The volume inside, you see the volume inside that we created, all the volume here, right? The volume is integrating x goes from A to B, and I need to integrate the area of this circle, which is pi fx square dx. So this is the formula which is called method of slicing. Method of slicing, because this area of a circle, this red thing is basically called the slice. Okay, this is called a slice. You see, when you have a bread at home, right? You see, you have a bread, let's say, there are slices of the breads, right? We take a knife and make slices. So if I pick just one slice from here, right, it will just have this type of shape, right? This is the slice of a bread that I brought out of the whole bread, one slice. So this is also a volume, and I just got one slice from there. So you take this slice and integrate from A to B. So basically you are adding up all the slices. You are adding up all the slices starting from A up to B, one slice after the other, 1 plus 2 plus 3, all slices from left to right. So this is what you are doing. So when you add all the infinite many slices from A to B, basically you have to integrate from A to B. So this formula will be given with the name method of slicing. You should know how to use it. So see here, it's written here, you see. If you see here, if you read this statement, let f be a continuous function, right? Let R be the region. Let R be the region that is bounded above by. So see, this is the region you have to look for your fx. What is the function at the top and what are the values A to B? You just have to remember this, and you have to read it that the solid of revolution generated by revolving about x-axis. So you have to be careful that we are revolving about x-axis this region. Then you make this solid, and the volume of this solid will come from fx. So the volume of this solid will be A to B, the values from A to B, right? And pi fx square. So you just have to put this function and the values A, B in the formula. Put the values a, b, and fx in the formula, you will get the volume of resolution. So let's say if I go to here, right? If you have, let's say this one, you see you have y is equal to f of x. So see, this is my function f of x. Between the values a is equal to pi and b is equal to pi by 2, right? So we have this. So if I draw any x in between, then this is the radius. So radius is f of x. When you rotate, it will become a circle, right? So this is the volume you will get. This is the volume you will get. So what do I need? I need just so 6.2 exercise 5. They gave me y is equal to square root of cosine x. And pi by 4 and pi by 2. Up from pi by 4 up to pi by 2. So this is the area. So I just have to see what are my a's and b's. So this is my function f of x. This is my a. This is my b. So if I just put it in the formula, therefore the volume will become a to b pi fx square dx. Okay. See, they did not give you cos x. If they give you cos x, your integration will become little difficult. Let's say instead of that, they give you this function, which is just cosine x. Y is equal to cosine x. It looks very easy, right? But the problem is when you write the integration, it will become cosine square x from a to b. And finding the integration of cosine square is not that easy. Okay. So that's why to make it easy, they gave you this square root of cosine x. And with the help of square root, now what will happen? Square root and square will cancel. So your integration will become very easy. It will become just cosine x. So integration of cosine x is sine x. Simple. Okay. But integration of cosine square is not sine square. Here, what is the integration? No direct formula. We have to use some trigonometric formulas. So now you can replace pi by 2 and then pi by 4. So sine pi by 2 minus sine pi by 4. First you put the upper limit minus the lower limit. That is section 5.3. Not 5.3, 5.6, section 5.6, fundamental theorem of calculus. That first you integrate and then you put the upper limit and then minus the lower limit. This is first. First this will go in, then this lower, then this. Okay. So now sine pi by 2 is 1 and sine pi by 4 is 1 over square root of 2. So you can write the answer. Similarly, if they give you a rotation about y-axis, let's say problem number 7. Now they say rotate it about y-axis. So what will happen? What we did with x, we will just change it to y. So x goes from minus, y goes from -1 to 3. So I will take any y in between and this will become my radius because now I am rotating it about y-axis. So instead of going down, it is going along y-axis. So this is the solid I made. So now I need this radius. So this becomes the radius, which is yx is equal to, you see, now this is your x. So what is x? 1 plus y. So my radius is this right hand side, g of y. So g of y is my radius. So if we exercise 29, exercise 7, page 429. This is also page 429. So you see, when the rotation is about y-axis, if you have a function here, x is equal to g of y now, and you are rotating about y-axis. So this will go there, this will go there, and I have this solid, right? So if I take any y, this is the radius, which is g of y. G of y is the radius, and slice will become this now. So this will be my slice. So it means now if I integrate, my volume will become from C to D. because my y goes from C up to D. So y goes from C to D and it will become pi g y square dy. Now it is not fx, now it is gx. This is my radius. So in our question, here you see in my question, gy is square root of 1 plus y and y goes from -1 to 3. So in exercise 7, it will become from -1 to 3 pi square root of 1 plus y square dy, because this is my g of y, square root of 1 plus y. Okay, so now again square root and square cancels. So you can integrate 1 plus y, it becomes y plus y square by 2 from -1 to 3. So you can find the answer. So if you revolve about y-axis, revolution about y-axis gives you y-axis here. Here, find the volume of the solid. If you look at this one, this 11th problem, here y is equal to 25 minus x square, y is equal to 3. Y is equal to 25 minus x square. It is basically a semicircle. You see, if I take the square, it becomes 25 minus x square. So if I bring x square here, this is circle of radius 5, right? We all know that it is a circle of radius 5 centered at origin. So this is a circle of radius 5 like that, right? But they gave you another thing. Y is equal to 3. This is 5, right? This is 5. But y is equal to 3 is here. 2, 4, 5. So 3 is here. This is y is equal to 3. Y is equal to 3. This is y is equal to 25 minus x square. And they say we are rotating it about x-axis. Rotation is about x-axis. Okay. So it means I am not considering this bottom portion of the circle. We are only considering this. So if I rotate this, it will come down like that, right? This will come down like this becomes this one, and you will have a circular thing. So it is a sphere with a hole, right? If you have a spherical thing and you put a hole in it, right? So it's just the sides of your sphere. So here, what you do when there are two curves in between, I will take x here, and now x does not start from the bottom. It is between these two curves. So now you see between these two curves, your upper part is this y is equal to g1 of x, and this is your g2 of x. Two radius now. It is between two curves. So here the volume of the solid will become from -5 to 5, because the other one is no, it will not be -5, because now I want this number. This number is not at 5, it is before 5, and this number. So I need these numbers. So you can put y is equal to 3 and get the answer. If you put y is equal to 3, so it will be 25 minus 9. So your x will become, if you put y is equal to 3 here, your x square will become 25 minus 9, which is 16. So x will become plus and minus 4. So these numbers are -4 and +4. So you are going from -4 to 4, and the pi g1 square minus g2 square, because now you have two curves. So you will subtract the squares now. So you can put the values. Square root of 25 minus x square. This is g1. Take the square, and minus second is 3 square. So this is gone. So you can integrate this and get the answer. So you have to understand the question where it is rotating and what is your fx, what is your fy, gx, whatever is given, the limits of x and y and so on. You can do another thing. You see, I can consider the same question. Let's say I considered a question, uh, y is equal to f of x, right? Let's say this is y is equal to f of x. And the region is given along x-axis. You see here, the region R is given along x-axis here. When the region is given along x-axis, we rotate about x in 6.3, right? In 6.2. And if the region is given along y-axis, let's say if I'm given the values of y from C to D, the region is along y-axis. If it is along y-axis, I will rotate it about y-axis, right? I will rotate it about y-axis. Things will become here, things will go there. This is the simple thing which we did in 6.3. In 6.2. In 6.3, they say that your region is still given along x-axis. Your region is given along x-axis from A to B, but they are rotating it about opposite axis, about y-axis. This is a strange region here. The region with x, rotation with x. You see the same thing. Region adjacent to x axis, right? And revolution again revolve about x-axis, same, right? If the region is with y-axis, revolve about y-axis, the same thing. But if the region is given with x-axis, but you rotate about y-axis, your region goes to the opposite side here. You see, your region will come here, right? After rotation, your region will come here. So it's kind of a cylindrical thing. You see here, when I took x here, this is the radius, and you get a circular thing. Your slice becomes a circle, right? A slice, which is a circular shape, right? So we call it slicing, method of slicing. Here, if I take any x between A and B, then this line is not coming down. This line is going to the opposite side here, and this red thing becomes a cylinder. It does not become a circle. You see here? So this red thing becomes a cylinder, right? And I only need the outside of the cylinder, not the inside area of the cylinder. So area of this cylinder gives me the area equal to 2 pi r h. Area of cylinder is 2 pi r h. So what is the radius here? You see, if I look at this cylinder, the radius is from 0 to x, right? So radius is x here. And the height is f of x, because when I take x, my height comes from this function. So height is f of x. If I make this cylinder here, if I make this cylinder, you see what you got. Between 0, you have x. So see, the radius is x. So the radius of base is x, and then you have a height. Height comes from your function that is given to you. See, on the black curve. You see, this height is on the black curve right here. So this height is your f of x, right? So it means my area of the cylinder becomes 2 pi x, 2 pi r is x, and h is f of x. So this is a cylinder, and I have to add all these cylinders, right? So when you have to add all these cylinders, you have to integrate. How many cylinders? Your x starts from A and goes to B. So x goes from A to B, and your area becomes 2 pi fx, and you have to integrate this to get the volume. So instead of getting pi x square, you are getting 2 pi x fx. This is called finding the volume by method of cylindrical shells. So this cylinder is basically a cylindrical shell. They call it. It looks like cylinder, but we don't call it a slice. It is a shell, which is cylindrical shape. So when I use cylindrical shell, it calls the method of cylindrical shells. Again, the formula will be given in your exam at the end of the paper, but you should know what formula I have to use. So remember, area with, or not area, I say region R with x-axis, but revolution about y-axis. But we are revolving it about y-axis, the other one. This was not the case in 6.2. In 6.2, both were the same. Area adjacent to x-axis and revolution is about x-axis too, the same thing. But in cylindrical shells, region is adjacent to x-axis, but the revolution is about y-axis. So if you go down here, let's see some question from here. You see, they give you the area. You see, the region is with R, but they say revolve about y-axis. So you are going this way. See, this type of shape you are getting, right? So I have to take any x here. Height of x comes from the function, which is this one. So this is my f of x. So I have to just put in the formula fx is equal to here. Your fx is the function, the right hand side of the function, and then a and b. A goes from 1 to x goes from 1 to 2. So a is 1, b is 2. I have to just use the formula. Therefore, the volume by cylindrical shells. Why I'm using cylindrical shells? Because this is not a slice. It does not become a slice. We had the area with x-axis. This line gives me a cylinder. You see, when I take this x, it gives me a cylindrical shape here. So I need a cylindrical shell, which they wrote here as well. Use cylindrical shell. So I can just put in the formula 2 pi x and fx. No square, 2 pi x fx. So first of all, 2 pi is constant. Now x and fx, they should multiply x cube dx, and then I will integrate, right? I will not just integrate directly. X and 2x, they will multiply first. This is x cube, so I will write x cube first. And now I will integrate, which is x 4 by 4 from 1 to 2. Then I will put 2 first, 2 to the power 4 by 4, and minus I will put 1. So it will become 1 to the power 4 by 4. So 16 minus 1, 15 by 4 is the answer. Okay, so in cylindrical shells, you have to be careful that we are going to the opposite side. In 6.4, you had a length of a plane curve. If a curve is given from A to B, we are not finding the region. We want to find actual length going from A to B, this length. The length of a plane curve is A to B 1 plus dy by dx square root and dx. So you have to find this function is y is equal to f of x, and you are looking for the length of the curve. So that is the formula. Again, formula will be given. You just have to find the derivative, put the derivative here and integrate. Okay. In 6.4, instead of rotating in 6.5, instead of rotating the area, you are getting a curve. We are rotating this portion of a curve, right? So this comes here. So if I do not include the inside, I am only taking this outside thing. This curve will only give me the outside of this solid, right? Only the outside region of this solid. What is outside? Only that is given to us. Outside surface area. Only outside thing, right? So that is called the surface area. That is not the volume. Volume is inside thing. inside is the volume, right? Inside volume, that was in 6.2, right? So outside is surface area, which is in 6.5. So if when I created this outside volume, I needed at any x, I needed this radius so that it becomes the inside area, which was pi r square. But now I need only the outside thing, this one, outside of the circle, which is called the circumference of the circle, not the area of the circle. When you consider the area of the circle, it will give you the volume. So you know that 2 pi radius, 2 pi fx. Radius is still f of x, right? This height is still f of x. So inside gave you the area. If I consider the area and integrate, it gives me the volume. But if I only take the outside circumference of the circle and I have to integrate this with the arc length, with the portion of this arc, this portion of this arc, this is the portion of the arc, this whole thing is called ds. Okay, so we have to integrate with ds, not with dx. So when you integrate, this gives you a surface area. So surface area is a to b 2 pi fx. And what was ds? Ds was 1 plus dy by dx. Dx. So if I only integrate, this portion, if I only integrate this portion, it gives me the length of the curve. But if I multiply this with 2 pi fx, which is the circumference of the circle, it gives me the area of surface of revolution. Surface area. It is not the volume, surface area. Okay. So these two formulas are given. So see, if I ask you this or this, right, you can use the formula accordingly. Both formulas will be given in the question, paper. You can accordingly find the volume, surface area. So let's see if I do a problem from surface area here. Find the area of the surface generated by, revolving about x-axis, right? So let's say if I take anything, difficult one, maybe this one, or first one, second one, y is equal to 6.5, exercise 2, y is equal to square root of x. X goes from 1 to 4, right? So they give you the portion of a curve. This is y is equal to square root of x, right? But they gave you only from 1 to 4, from 1 to 4. So this is your, but I'm not looking at the area. This is the surface of revolution. So it means I only need the curve here. I'm only rotating the curve, right? So my fx here is square root of x, the given function. A is the lower limit, b is the upper limit. So I can just put it in the formula. Therefore, the surface area is from 1 to 4, 2 pi fx, 2 pi fx into 1 plus dy by dx, which is 1 over 2 square root of x. So basically, you have to find that derivative as well. This is your y. So your fx is this. So you need dy by dx as well. So dy by dx is 1 over 2 x to the power minus 1 by 2. So this becomes this. Okay. So from y, you need the derivative. So you will put fx here and dy by dx here. This is y or fx, whatever you can call it, y or fx, whatever you call. Y and fx are the same thing. And dy by dx or f prime is the same thing. So see, I put the value of fx, I put the value of dy by dx. Okay, so now you can just integrate this and get the answer. To integrate, you have to simplify this first. Okay, first simplify. You cannot integrate it directly. You have to simplify it first. So in simplification, You got from 1 to 4. Square root of x is outside. Here, you have to take the LCM, 1 plus 1 over 4x, right? 2x square means 4 square root cancels, so 4x. Now you can multiply, because it's a multiplication, you can write these both in one integration. You can put just one integration and write x into 1 plus 1 over 4x, right? So now you can multiply x with both of them. So you got 2 pi 1 to 4. X into 1 is x plus x into 1 over 4x. X cancels. So you got just 1 over 4 power 1 by 2 dx. And now integration becomes easy. With respect to x, you just have to integrate x plus 1 over 4. Because it's a linear function, so you can still add the power by 1, divide by the same one, and get that. All right. So that's how you can use the. So you should know which formula you have to use and how to find the unknown things in your formula. If this formula is written for surface of revolution, but you do not know what is your f of x and what is dy by dx, right? So then it's of no use. This formula will be of no use, right? So you should know what is my function. Function is given to you. This whatever curve is given, that is your f of x, right? The right hand side. And then you have to find the derivative dy by dx and put these two values in the formula. So dy by dx will go here, fx will go here, and formula will become this one. Then you can simplify and integrate. The last thing which I did was curvature. And again, you see, if your curvature is basically the bend of the curve, the twist, right? If something is going straight, there is no bend, no twist, right? No bending, twisting in the curve, right? So this means that your curvature is 0. Curvature gives you the measure of twist, then the curvature is 0. If there is a bending like this, right, or twisting, then you should have some curvature. The more bend, curvature big. Small bend, curvature small. Okay. So if it is more bend, more twisting, then the curvature will be big. Curvature is written as kappa, right? This is not K. This is K-A-P-P-A, kappa. So this line is like little s, right? Prolonged s, but then we make it a k. So it's a kappa. Kappa is a function of x usually. If your function is y is equal to f of x, and at any point, curvature is found at a point, not on an interval. Okay, so at x, what is your curvature? Usually curvature is a function of x. It is the second derivative of your function and absolute value of that, divided by the same arc length function dy by dx. But the power is not 1 by 2, the power is 3 by 2. So this is the formula of curvature which will be given to you. You can easily find. As I said, in 12.5, there are questions about curvature, but don't go through 12.5. Just only look at the formula. It's 12.5 is not given here. So I can just write something. For example, if you have, let's say y is equal to sine x, right? And you want to find curvature at x is equal to, let's say pi, right? Your sine x starts from 0 and at pi by 2, let's say pi by 2 is better, I think. Because pi by 2 will give you a maximum bend. At pi, your bend may be 0 because it looks like a straight line here, right? So curvature may be 0. If you have y is equal to sine x, I need first and second derivative. dy by dx is cos x, is the first derivative, square of the first derivative, and then the second derivative. So the derivative of cosine is minus sine x, right? So if you put the values, so at x is equal to pi by 2, your values dy by dx becomes cosine pi by 2, which is 0, and second derivative at pi by 2, which is minus sine pi by 2. Sine pi by 2 is 1, so it is minus 1. So now if I put these values in the formula here, right, your curvature will become, for this question only, your curvature will become mod of minus 1, second derivative, 1 plus derivative is 0 square, power 3 by 2. So this will become 1, right? Absolute value of minus 1 is 1, and this 1 plus 0 is 1. And 1 to the power 3 by 2 is also 1, right? So your answer is 1. So that is the curvature. This is the maximum curvature. You can change the point and get some other value. Maybe you can take pi by 4, which is here. You can find the curvature at pi by 4. You can find the curvature at pi, maybe at 0. You can find curvature at any point, but the point will be given in the question. So this is a very simple topic, I think, free marks. If this formula is given, you just have to find derivative and second derivative, put the values here, get the answer. Very simple formula and very simple calculations in curvature. So it's, I think, one free question is this one, because you can get the maximum marks. I think I did not start with chapter 4. In chapter 4, 4.4 plus 4.5, these were absolute maximum minimum problems. You know that for maximum minimum problems, you need critical points and then second derivative to show that whether it's maximum minimum or not. So if I give you some problem and you ask you to maximize or minimize, so here, see, there are some problems that are applied problems. For example, here, if you see this example 1, example 1, example 2, example 3, and these are, I did something from exercises as well. So maybe I can do that. Let's say first I did these. If you look at the videos that I posted on Moodle, we did these in detail. Example 1 on page 4, 250, 275. A garden is to be laid out in rectangular area. You see this one, a rectangular shape, and protected by a wire, chicken wire. What is the largest possible area if 100 running feet of wire is given? So 100 running feet of wire is given, so you can make different. For example, you can make 20 plus 30, 20 plus 30, 20, 30, then 20, 30. It's rectangular and all 100 meters are used. 100 feet are used, 30, 30, 60, 20, 20, 40. So 60 plus 40 is 100, right? Or you can maybe make 25, 25, 25, 25. This will also give you 100, but volumes will be different. You see, here the volume will be 32, 30 by 20. So the area here will be 600. But here, if you multiply, the area will be 25 into 25, 625. So this is bigger than this one. So I should prefer this, not this. But how can I make sure that this is the largest area? There is no area more than that. So what I can do, I can define variables. I can say that let X be the length of the garden and Y be the width of the garden, right? So I can see this, and A be the area of the garden. Now we know that if X and Y are the length, then area is XY. Area is XY. But here we have two variables, XY. I need one variable only because I cannot handle two variables in my maximum minimum problems. So they give you a condition. They said the running wire is 100 feet only. So I know that it should be X plus Y plus X plus Y should be 100. So x plus x 2x and y plus y 2y. So 2x plus 2y should be 100. So from here, you see I got y is equal to 50 minus x. I will put it here. When I put it here, area will become x into y. Y is 50 minus x. So I got one variable here now, you see. So I got one variable. Now I can find the maximum and minimum. Finding maximum minimum is finding the first derivative, putting it equal to 0, right? So for maxima minima, first we find the critical points. Critical points are where the first derivative is equal to 0 or first derivative does not exist. Sometimes there are points where it does not exist. Those are also critical points. If you have a closed interval, then it's easy. You got critical points. If you are looking absolute maxima minima on closed interval, let's say. Okay, on closed interval AB. Then what we do, we find the critical points. Let's say x is equal to c is a critical point, or maybe more than that, c1, c2, etc. are critical point. Then what we do, then we evaluate our function. We evaluate our f at critical points at c1, c2, etc. and at endpoints AB. So what we do, we just find, let's say there are critical points like that. This is your C1. This is another critical point C2. And you have first point A and the last point B. So what I will do, I will find the function value at A. I will find function value at C1. I will find function value at C2 and function value at B at all these points A, C1, C2, B. If there is any C3, I will evaluate C3 as well. So we will find the values and I will see which one is highest and which one is the smallest, largest or smallest, right? So the largest value give me absolute maximum. And among these, if we have any smallest value, the smallest value give me absolute minimum. So it's very easy on a closed interval, right? So for example, in that in example one, my area problem became 50x minus x squared, right? 50x minus x squared, this one. And the interval was from 0 to 50, closed interval, 0 less than or equal to x, less than or equal to. So see, it is a closed interval. So first of all, I will find the critical point. Finding the derivative, which is 50 minus 2x, put it equal to 0 and get x. X is 25. So only one critical point. So I have end point, I have critical point, I have another end point. So what I will do, I will find the function value at 0, function value at 25, function value at 50. At 0, it's 0. At 50, it is 0. At 25, it is 625. The function value. Put not f, it is area. My function is area basically. A at 0, A at 25, A at 50. You can see that 0 minus 0 is 50 into 50 minus 50 square is also 0. But 50 into 25 minus 25 square is this one. So which one is largest? So this one is largest, right? They are asking me to find the maximum area. So I'm only looking for the largest value. So we can say that your area is maximum when area is maximum when when x is 25, right? And when x is 25, what is my y? Because he asked me the dimensions. Dimension means both x and y. What he asked me the largest possible area, so I can find the largest possible area. Therefore, maximum or largest A, maximum or largest A is A at 25, which is 50 into which we have already calculated, which is 625, which we have already calculated. So this is my largest area, and this was the area when my sides are 25, 25. Okay, so this is, see, the first part, this part is 4.4. This part is 4.4. When function is given, interval is given, that's how you find maxima minima. That is 4.4. But before that, how we made this question, before that, how we made this question from here to here, this is new thing 4.5. Okay, so you should know how to make a problem and then finding the maximum and minimum value. For example, here you see this is very interesting problem. An open box is to be made by 16-inch by 13-inch piece of metal. So the original metal piece was 16-inch by 30-inch. He said, we are cutting out squares of equal size. We cut out a square from here. We cut a square from here. When we cut, we throw it away, right? So now this is gone. And I bend it. If I bend it up, right, I have this type of box. You see, from here, I bend all four sides. So see, now it has walls as well. Four walls, and there is no top here. That's why they call it open top. So what will be the new dimensions of the box now? 30 was the height. 30 was the height here. We remove x from here. We remove x from here. So what is the remaining? Remaining is 30 minus 2x. This one remaining is, this is my length now, L, right? Here it was 16, but 1x I cut from here, 1x I cut from here. So the remaining length, width of this box is now 16 minus 2x, right? So width becomes 16 minus 2x and L become, and what will be the height? Height will be the measure of the square, because when I bend it, this height will go up. So see, x will become the height, h, right? So now what will be my volume? He said, what is the volume? What size should the squares be? What x should I take so that my volume becomes the largest? You see, if I take a big x, my walls will be higher. When I bend, my wall will be higher. To make a wall higher, my length and width will become little smaller. So my box may become something like this if I take a large height, right? But when I take a small height, then my floor is little bigger. Height is small, floor is big. So I don't know which one gives me the more volume, right? We are not sure which gives me the more volume. So we are deciding. Now volume will become length into width into height. So length is 30 minus 2x, not 30. Height of length of the box. This is not the length of the box. This was the length of heat. We removed these 2x and x. So length of the box becomes 30 minus 2x. Width of the box becomes 60 minus 2x, and height of the box is x. So see, we have only one variable here. So if you go down, you see this one, right? 50 width, length, and height. You can write anything first. So you can multiply it here, then multiply x. You got a function of x in one variable only, right? So again, instead of area, you got one variable problem. So again, I can take, so see example 2 on page, same page, no, 277, I think. All right, 276. 276, 277. Okay, so important example 276, 276. So you can see this example completed because the difficult part was getting the function. I got the function x into 30 minus 2x, 16 minus 2x. When we multiply, we got the variable. Now your x has to be less than, x has to be positive, right? It cannot be negative. X has to be positive because it's the height. But what can be the maximum value of x? Can x be 16? X cannot be 30, right? Because the lower side is 16. We know that x has to be less than 16. But we are cutting out squares from both sides. We are cutting out square from both sides. If I take x is equal to 8 and 8, this will be gone. volume will become 0. So it means x cannot be more than 8. X has to be less than 8. 30 is the bigger one. So we take the smallest length, half of the smallest length, half of the width, basically, not the length. So 8 is half of the width, the smallest of both, right? Which is width. Length is actually the bigger one, which is half of the width. Width of the sheet, not width of box. Width of sheet, the original sheet, because we are cutting out square. If the 16 is the width, so at the most I can take 8, but at 8 my volume will be 0. So you will take the first derivative, put it equal to 0, find the critical points. Now evaluate your function at 0, evaluate your function at 8, evaluate your function at critical points, and see which one is the largest. See which one is the largest, this one or this one. Okay. So let's see if we have anything from exercise. Uh, I did some problems from exercises, so you can go to Moodle, watch the section 4.5. I have done these problems. You can see I have done these problems uh, in that video. See here, I think this one, right? This is a question like example 2. This one is a question like an open box is to made by 3 feet, 8 feet rectangular piece of paper. Exact same question. These are garden. First example, a garden is to be laid out. See, a rectangular garden is to be bounded by the fence of 3 sides and by a straight stream on the 4 sides. Similarly, there is some cylindrical problems as well. A cylindrical problem 31. I did this problem in that video as well. A cylindrical can open at top is to hold 500 centimeter cube of the liquid. So if you have a cylinder, you need radius and you need height. And the volume is pi r square h, right? But they said find the height and the radius that minimize the amount of material. Amount of material will come from the surface area. Okay, the surface area of the cylinder is 2 pi r h, right? 2 pi r h. So you have to minimize this. So s is your given function. This is your function, and volume is fixed because he said 500 centimeter cube is the volume. So this will give you h in terms of r, 500 divided by pi r square. That you will put here to make it a function of one variable, 2 pi r into 500 by pi r square. So see, you got surface area as one variable, r. So they gave you this condition so that your surface area can change to one variable, because in surface area there are two variables, 2 pi r h. If you look at the video, this problem is also done over there. So I think that's pretty much it. I think I have covered. So of course, every lecture has a video on Moodle, notes as well as the video. So don't only rely on this review session. Of course, review session will give you idea about how the exam will be. But if you want to get full marks or better marks, you should go through all the lectures that we did from time to time. And I am sure that you have already been watching and going through it. I can show you here. So see here, I think I tried writing these. So see, this is
It's written C 4.5. So if you go to 4.5, you see I have done example 1 here, example 2 also did there, right? And then I said see example 3 on page 47. I did example 5. This is the cylindrical can. In that exercise, they made this 500. Instead of 1,000, they made it 500. So only this volume, this will change. Pi r square h will become 500. So h will become 500 by pi r square. That's what you will put in the surface area problem and you get the answer. So this will give you a lot of practice, I guess. So see, I even did question number 1, 2 from the exercises and left others to you, right? So if you can do these 5 problems, I think you can ace this question in the exam as well. So videos are also, I think, recorded and posted over there. If you can see, YouTube videos are there, right? So if you have any questions, let me know. I think I am done. Right? So I can only wish you good luck now. Hopefully you will do better. So this review session will give you, of course, some preparation, but maximum preparation will come from the other videos. So I can stop the recording here. But still, if you have questions, you can ask me. If you have